Hello everyone, my name is Sofia Garza and my partner Carlos Gonzalez, and today we'll be talking about the performance of facial recognition between different processors.
For our overview, we'll be talking about our objectives for this project, as well as our motivation of why we wanted to work on with facial recognition. Then we'll talk about what facial recognition is. We'll try and answer all your questions on what facial recognition is, how is it helpful, what it does, and where it can be found. After that, we'll talk about the different type of processors we use for this project. And then we'll talk about a little bit about our methodology, the data set that we used, what we did to get the results that we wanted, as well as what type of results we were trying to look for and get. Then we'll talk about our results, and finally we'll end up with a conclusion.
The objective and motivation. So, machine learning, it's a hot trend that's been growing over the past few years, and machine learning is something that is used to solve problems and even improve our daily lives. An example of a machine learning algorithm could be something as simple as YouTube. This actually takes the preferences on the type of videos you watch and it puts it together and it recommends you videos that you might be interested in. And that's just a simple algorithm that we might use every day. And for our project, we wanted to use a machine learning algorithm called facial recognition, and we wanted to compare the performance of three different processors, which would be the Raspberry Pi, the AMD, and the Intel. And this is to see which of these could give us the highest performance and also what gives us the most cost-effective solution. So a little bit about facial recognition. It's a technology that's capable of matching human faces from a database, and this database could be either images or video based. So it does this by using geometry. An example might be it could measure the length between the eyes or even the length of a nose. And this technology, it's found in smartphones, security systems, retail and advertising. I think the most popular one might be a smartphone because it uses your face to open or unlock phones. And to see the huge demand of this particular algorithm, we'll see that the market was valued at 3.83 billion in 2020, and it's projected to reach 16.74 billion by 2030.
Okay, so a little bit about our processors. The first one we're going to talk about is our Raspberry Pi. This is a low-cost computer, starting around $35 for depending on which model you're looking at, going up to around the $100. This computer can works using a Linux-based system based on Debian, and this system the capabilities of this systems is you can play games on it, browse the web, or do some low computing programming. And this system also has GPIO pins. This GPIO pins allows us to connect hardware to it, such as a breadboard, sensors, or LED lights. For our processor, the AMD processor, this is I would say the high-end processor that we're using for this project, since it is a costly processor. It starts at $449 original price, but since it is like around 2 to 3 years old, the price has come down to $249. This processor is compatible with Windows and Linux, and the capabilities of this processor, again, we can play games on it. We can do some image rendering or programming. The programming for this used for this processor, it's a little bit more intensive compared to the Raspberry Pi. since it has more cores, allowing us to do more intensive programming. And the thermal design power. The thermal design power is how much stress we can put on the CPU. So for this processor, we can go up to 105 watts, but nothing higher than that. For our Intel system is, would say it's our medium cost processor since it starts at 399. But again, it's a few years old, so the prices come down to 219. And this processor can work with Windows, Mac OS, or Linux. And the capabilities of the system, just like the AMD system, it can play games, render images, and do some programming. And the thermal design for this processor is 65 watts. Compared to our AMD system, this processor cannot go as high since it has a lower thermal design power. Next, we'll talk a little bit about our methodology. So for the specifications of each system, first I'll start with the Raspberry Pi on the left side. The Raspberry Pi, the processor for the Raspberry Pi, it is a 4-core processor, which that has a 1.5 gigahertz frequency. And for the RAM, it has 8 gigabytes allocated to it. The next processor in the middle, our AMD system. This is an 8-core processor with 4.7 gigahertz of frequency. And this system has 32 gigabytes of RAM. And finally, for our Intel system on the right side, there's a 6-core processor with 4.1 gigahertz of frequency. And for the RAM, it has 16 gigabytes.
So for our setup on this project, we first start off by trying to get a data set. And to do this, we went to an online repository that had thousands of images of people. And what we did is we'd reduce this amount to 3 different sizes of data set. So we'll have the 20,000 pictures, 40,000 pictures, and 60,000 picture data sets. And these do have the same pictures, which contain different people and different resolution and sizes of the images. And once we were done making the data set, we inserted into a Python-based algorithm that processes the image itself and gives it a classification of person as well. And to do a fair experiment, we did an isolation of the execution, which means that we killed any process or program that was running in the background that was not needed for the computer to run. For example, if I had a web browser open or Microsoft Word open, we closed those so that we could reduce the noise or the resources going to the wrong program. And this just helps us get fair results for the algorithm itself. And the performance metrics that we got for this experiment were, the first one is the CPU wall time. This is equivalent to starting a stopwatch once you start the program and stopping it once it ends. And then we got the CPU execution time, and this is the actual time the processor actually took executing and running the program. So this time is going to be lower than the CPU wall time. And then we got the CPU usage. This is a percentage of how much CPU usage was used during the execution of the program. And also we got the memory usage, which is also just a percentage of how much memory was being used during the process. And we got all these metrics using libraries from Python as well. In our results, We'll be discussing the 20,000, the 40,000, and the 60,000 datasets. We could see that for the CPU usage, the AMD had the lower um, amount, followed by Intel and followed by the Raspberry Pi. And it's a trend amongst these three that these go in the same order. We believe that this order is due to the amount of cores that these systems have. The AMD does have 8 core, the Intel has 6, and the Raspberry Pi has 4. So it kind of goes in order on how many cores these have, because having more cores does allow more instructions or more processes to be run at the same time. And yeah, and so now we go on to our memory usage, the 20,000, the 40,000, and the 60,000 again. And now we have the Raspberry Pi coming in the lower this time, followed by AMD, and then followed by Intel. Again, for all three graphs, this is the same. We believe that the Raspberry Pi is the lowest because it does have the most memory, the least memory amongst these. It has 8 gigabytes, followed by AMD, which has 32 gigabytes, and a little bit of a curveball that we got here is the Intel having 16 gigabytes did come above the AMD, and we don't know exactly what the reason for this being, but it's something to keep in mind and further research.
For our CPU wall time, no, execution time, we can see that for the 20K, the Raspberry Pi was the system that took the longest compared to our AMD and Intel. Our Raspberry Pi took 12 hours, while our AMD and Intel were on par with each other, around 3, almost 4 hours. For the 40K, again, we can see that our Raspberry Pi took the most time executing these processes, while again, our AMD and Intel are on par with each other around the 8-hour mark. And finally, for our 60K, the Raspberry Pi took a whopping 36 hours, while again, our AMD and Intel are on par with each other, taking around 11, almost 12 hours to execute. Conclusion. So some of the challenges we had while do with this project. First, when running this algorithm, we had some problems with some images. So whenever we're running the program, if some images weren't the specific format, if it wasn't a JPEG or a PNG, the program would just crash and we would have to start from the beginning. So what we found out is that if the image is anything else than a JPEG or PNG, because this was an online repository where we got the pictures from, some of the images were classified as GIFs, it's an image that moves, or it's not a solid image, so it has movement in it, making the program not be able to detect it correctly and giving us an error every time. And some of these times when we figured it out, or the first few times, we were already running the program, and by close to the end, when it was missing around 50 pictures, it would just crash on us. So to go around this, we had to make an exception in the program that whenever we had an image that was not the format that the algorithm wanted, it would just skip it. Or and for some cases, before this, we had to go in and delete them manually one by one for each data set.
And to conclude, we want to emphasize that as machine learning is evolving, we also want to see how to improve the computer systems, because at the end of the day, the computer systems and these processors, they're the ones that are allowing these machine learning algorithms to run efficiently and to the best quality possible. So it's important for these machines to keep improving as well. And in our research, we found that memory is a huge performance bottleneck. For example, the Raspberry Pi did suffer a longer execution time because of its memory constraints. So it's something that's very important for this type of field to run the algorithms. And we also found that AMD and Intel were similar in execution time. However, Intel used more computing resources, which is interesting, to probably do some more research in the future to see why the reason is for this. And that concludes our presentation. Thank you for listening.